Hey folks, welcome to Advent of Code, day 2, in F#, of course. Yesterday was a bit of a rough start. Part 2 was a bit more challenging than I'm used to for the first Advent of Code puzzles. So here is me hoping that day 2 will go a bit smoother. Let's drop right into it, shall we? Day 2, Cube Conundrum. You are launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land on a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Oh, why yes we would. As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play the game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay, to get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back. He'll do this a few times per game. Okay. We play several games and record the information from each game, which is our puzzle input. Each game is listed with its ID number, followed by a semicolon separated list of subsets of cubes that were revealed from the bag. Okay, it's just like a random grab and there's this many reds, this many greens. Makes sense. So we have a list of games, multiple grabs, each with potentially red, greens, and blues. Is there always a red, green, blue? We'll see. So in game 1, 3 sets of cubes are revealed. 1, 2, 3, yes. And then put back. Okay, the first set is whatever. That all makes sense. The elf would first like to know which games would have been possible if the bag contained only this many cubes. Okay. Yeah, I see some problems here. So in the example above, games 1, 2, and 5 would have been possible. However, game 3 is impossible because of these 20 reds. Yeah, that all makes sense. And then we need to add up the IDs of the games, so we have to keep track of the IDs as well. And we just determine the sum of the IDs of possible games. That sounds doable, cool. Let's grab our input. And let's put it in a file somewhere. And let's also grab the example. We have something to work against and to verify whether our code is doing somewhat relevant stuff. Double click is not working. Something is up with my IDE today. I was not able to press tab 10 minutes ago. Now I'm not able to press my arrow keys or my double clicks. If this is Visual Studio 2023 .NET 8 stuff, I am not impressed. Wow. Seems like it's stuck in a control or an alt. Okay, it was stuck in some kind of a button press. So that was me ranting on irrelevant stuff. Let's get started here. How will we tackle this problem? I would like to parse these lines first a bit so we don't have to do a lot of string mangling when we're doing the calculations. So let's try the lightweight parser for this. I always like to parse into types because types are pretty easy to declare and work with in F#. So let's think about types. Let's declare a game type. I'm gonna do this right here. So let's declare a game type. And it's a record containing data, and the data is the game ID. Let's make that a number. And then just counts for each of the colors. Yeah, I'm just gonna do it like that. So we have number of blue, number of reds, and number of greens. Yeah, that's more than good enough for what we need. And that's also an integer, of course. Let's try the parser. So I'm just gonna map over the input and parse the lines. And let's write this parse function. It's a function that takes a line as a string and it returns a game. These parentheses is unit, it's a bit like void, we return nothing. That's just to get the compiler to not complain while we think about this. I think regular expressions might be a good match for this, so that's exactly what we're gonna do. Where are regular expressions again? Yeah, okay, and we can provide a pattern here. Let me open this up, this namespace, so we don't have to fully qualify it. There we go. So we have a regex and we want to parse out the game ID and the counts. How do you do that again? How do you capture stuff in a regex? This has been, I only do this for advent of code parsing using regexes, so I'm a bit rusty. What was the syntax again? Is it something like this? I'm not sure. I'm gonna play around with it for 1 minute, and if I don't find it, let's look up the docs. And let's match with whatever. Oh yeah, there's a semicolon. This is not going to be as easy. It's going to be a repeat. Let's just parse one repeat first, and then we'll do the semicolon thing. What's it called then? Groups, matches, groups. Oh yeah, it's groups. Okay, so that's not what I'm looking for. Is it parentheses? No, okay, time to look up. Time to look up regex basics. .NET. It's parentheses. Should be able to define a group with parentheses and dig into it with the groups, yeah? That's exactly what I'm doing, I would guess. Let's take a quick look at that again. So parentheses. Oh, yeah, of course. Silly me. The rest of the regex has to match, of course. So let's take this and let's hard code a game ID in there. And let's forget about everything else just for now. We'll build on this in a second. This should work, right? There we go. Now we have stuff. Yeah, we have a match, and if I look at the value of the first group, which is the second element in the list, because the first thing matches on the entire line, because who knows? It's matching on value 12, and that's exactly the game ID. So we have a beginning here. Cool. This will work, this regex thing, but it's non-trivial. It's like a list of colors, semicolon separated, and then it's a list of hands, of comma separated, sorry, and they are semicolon separated, so it's a list within a list. How does that work? Lists within lists and groups. Will that actually work? Or should I be digging to more advanced parsing than just one single regex, because my regex game is not very strong, let me tell you. I almost feel like grabbing a parser library, but for day 2, really? That would be very soon. You know what, let's just, it's a very defined structure, right? Game, open, and then you have very separate things. We can do a lot of string splitting on these markers here. Let's keep it very basic. Just to say that my regex game really is not up to par for even this magic. So if you are doing this in regexes, please give me a shout. I would like to look at this beautiful one-line regular expression to parse this whole thing. But I'm not gonna do that. I'm gonna do some string split magic. So my valiant efforts of using regular expressions stop here. I'm sorry, Maarten. Your legacy will not be forgotten. I had this one colleague who was like crazy into regular expressions. But that is not me. So let's use string splitting here. First, let's grab out the game ID. Is that how I do it? Split, what does that return? An array? I think I can pattern match on array, right? Let's grab this as our first line. It has to be lines, so we have to split lines. That's something for... oh, we're doing that. Okay. Yeah, sorry, I'm getting confused. There we go. Let's parse the game ID. Game split on space. So this is really, really artisanal parsing here. But if it works, right? We can clean up later. So this is the game ID. Let's make that a number. There we go. And now let's just write some parsers for the hands and the individual color counts. Is hands a good term for what this semicolon separated thing? Subsets of cubes that were revealed from the bag. I'm gonna call that handfuls. So let's parse the handfuls. So there's a lot of trimming that needs to be done. There's a lot of spaces before and after, so it's not the cleanest of parsing. I'm gonna get rid of that space in that initial parse. So yeah, now we have our hands somewhat. There's a lot of spaces in there as well, but that's not a problem. We can get rid of them with the same hacky approach by just splitting on space. I think so too. I think so. That looks correct, right? That's one, that's one, that's one. That looks correct. So let's parse these hands. Let's write a little helper function, parse hands. Let's make it a nested function. Nobody needs to know about its existence. And let's just have it return like 3 counts, or let's have it return the game. Let's have it return the game, yeah. So we can just provide the game ID. No, that's not what a parse hand should do. I'm just gonna have it return a tuple of blue, red, greens of the counts. And before we dive into hands parsing, let's return the game with the game ID. Now my dollar is falling, or we have like a list of hands, but it's a list, and our game type is like not a list, so that this is really not what we're parsing here. So we're parsing hands. So let's make a hand list, and let's make a hand type. This might be a bit overkill for today's problem, but it'll set us up for success in the coming days. Dear compiler, would you please? Unmatched parentheses. I'm not even sure what the compiler is trying to tell me here. That looked like valid syntax to me. Oh, this equality sign, this is a bit off. It's a type declaration, not a... Now, I'm just curious, could I not put these on new lines without a semicolon? You could. Compiler was just confused, but that's not a problem. Okay, so now we can parse game ID, yes, and we can literally have this thing return a hand. So we will be spending more time parsing than we will be actually solving day 2, but that's a trade-off I'm willing to take. The red squigglies, they take too long to disappear. That's new since the new Visual Studio upgrade. I'm not a fan of it. But anyway, we have our hands, and we can just provide those hands to our constructor here. I cannot believe how long it takes. Okay. Game ID is not defined. That's a typo on my end. Hands is an array. Should be a list. Let's just make it a list. That's a warning saying that this pattern match might fail or this structure. That is very correct, but let's not worry about that. Okay, finally, we can parse our hands, which we'll just take this part, right? So it's splitting on a comma and then parsing whatever we have. And split on a comma. Let's grab one of those hands. What's an interesting one? One where not all three colors are like there. Yeah, the first one is an interesting case. I'm just gonna inline that real quick so I can play around with it. There we go. We split on color counts. Or we split on comma, sorry. And then we have these things, and then we can just parse each and every one of them. And same thing here. Let's write a parse color. Actually, we need to know whether it's red, blue, or green, right? We really need to know. Am I gonna make it even more difficult? I am. So let's define a union type. A color, which is blue or green or red, and have a hand be a tuple of a color and a count. So this is me changing my mind 5 times already. No, 3 times. Cool. And hands should be a list of hands, and a hand is a tuple. Yeah, that should work. So the only thing that will change is this should be a tuple. A list of tuples. 1 blue, for example. That should all parse, right? And that is all parsing, cool. Except hand does not match type color int list. It's a list of a list. Yeah, that's true. It's a list of a list. So hand is a list of color ints. I'm chalking this up to my illness last week. My brain is still fried. I'm really slow. But we are getting there. Slow and steady wins the race, right? We have a color count. Let's just parse that now into what would this thing be returning? Hand is the entire hand, so this is returning a color count, which is this thing. Let's put the type hint in there in order to keep ourselves on track. So we have a color count and we want to parse out the color and the count. That's another string split in my book. So it's a color and a color. Color, is it within U? Probably. Is it like USA versus UK? Oh, I'm US English right now. I prefer the UK. I'm gonna do it. I'm gonna replace color by color. Just because I'm a stickler for details. There we go. So we parse our color and our count by splitting the string. Those are space separated. And let's then parse them into our relevant types. So our count is the raw count parsed into a number, an integer. And our color is, let's just do a pattern match. Blue, lowercase, should be blue, our union type, and the same for red and green, right? It's been a while since I've seen my code working. That's not an ideal way of working, but okay. So we have color and count. It should say that there's not enough matching going on, but it'll crash if it crashes. I think this is good enough. Okay, so then we have our hands and we just put them in. My compiler is happy, so I'm happy. Let's see what this gives us already. It gives us something. ID 1, let's take a quick look. ID 1, blue 1, blue 1, blue 1, blue 1, blue 1, blue 1. I think something might be wrong here. We have a hard-coded hand in here. Of course we do. But that's not even the problem I was seeing, I guess. Interesting. Where is this blue 1, blue 1, blue 1 coming from? What does example look like? That looks very cool and correct, and there is not a blue one in the first hit, so we hard-coded something. Let's take a look. Yeah, looks correct. What does a parse hand look like? Oh, here's blue one. There we go. And make that a list again so our types line up. There we go. This should be better. And we have a match fail. Blue was not in the correct value. Sorry. What are we trying to do? We're trying to parse an int to a blue to an int. That's not what I was supposed to do. Oh, it's first the count and then it's the color. One blue, not blue one. Okay, okay. That's a mistake. That looks better. I can't believe how long it's taken me to parse input here. But we're getting there. 3 blue, 4 reds, 1 red, 2 greens, 6 blueies, and 2 greens. That looks correct. I'm comfortable enough to call this a working parser for a definition of the word, but it's working. Let's see if it works on our input. We get something. Good enough. So now we can go to actually solving the problem here. So we have a constraint, and we need to look at how many of these games are possible. So let's take this constraint. It sounds like we are doing a filter, like filtering out only the possible games. So let's write a Let's write a filter for that. So games list filter is a possible game. And let's hardcode what it means to be possible in the function itself for now. Let's make every game impossible. There we go. So when is a game possible? When in one of the hands we exceed the maximum we have here, right? We don't need to sum up any games, we just need to look at every hand individually because they're all randomly and they go back into the bag. So let's do that. So yeah, game hands. Let's give it a type in, so we're working with games here. I was confused with gems. Shout out to Space Gems. One of my colleagues is prototyping a board game. It's called Space Gems, and it's a board game, so I'm super confused here. But anywho, let's see when a game is possible. So for every hand, we need to satisfy this constraint. So let's just do a is possible hand. What's a hand? It's just a hand. So let's put that in there. It's the hand type, and a hand was a list of colors and counts. Yeah, so a list is maybe not what we need. Do I want to make this a lookup table? No, let's keep it a list, but in a essence, it's a dictionary or lookup table. We can't have like 2 hits for one color. Anywho. So let's find the one for green or red. So this is the count for red. For green and for blue. Yeah, that's enough. So if red count is smaller or equal to 12, or that's just the condition we need, like, right? So this should be true, and green count should be 13 or less, and blue count should be 14 or less. So I'm thinking that this should probably work. Probably. Let's give it a try. Of course not. Key not found. Cool. Oh yeah, it could be that it's missing. Okay, now that I see this, I am tempted to make it into a map. But not just yet. Let's work with it. So what's happening is it's a list of hand counts, but not all counts or not all hands have every color in there. For example, here's one with only green in, and if I try to look up blue, it'll fail. So I'm just going to do, instead of a find, I'm going to do a try find, which does exactly the same thing, except if you look at the type signature, it's saying it does not return a t, so it does not return a tuple, but it returns an option of a t. So this, when it finds nothing, it gives you a nothing. If it gives you something, it gives you a something with that value, or a none and a sum. So if you do try find, now you have an option. And you can do stuff with options, like say option default. Yeah, you can use option.default value or default width, and that's things you can use to, like, okay, if I don't find anything and there's a reasonable default value, you can take this instead. So if I say option default value red 0, then if it does not find anything in this lookup table, it'll give me this instead. And if it found something, it will of course give you the counts that were in this list. So we can use this to handle the fact that not every count has every color in there. I'm just gonna do this. Copy paste. The rule of 3 applies here, but we'll clean up later. So now we can handle missing data in our counts or in our hands, and that should give us a bit more bang for our buck. It is actually doing something cool. So now we have our possible games, which are 1, 2, and 5, according to my code. And that seems to be correct, and we just need to sum them by game ID. I think this should be possible. Possibles is a list of games, yeah. You can do this underscore hack since .NET or since F#8. You should be able to do this. Oh yeah, it's not game ID, it's ID, sorry. Usually you have to do this game, you have to define the lambda. But since F#8, you can just do a shorthand with an underscore. It's a syntactic sugar for exactly the same thing, but it's a bit shorter. And yeah, we have 8, so I think this works. Let's put it in a function. And let's return the solution. And let's run it on the example. And then we can run it on our input, of course, as well. So this should give us 8. Yes, I'm gonna plop this in a test. My control key is stuck again. This is getting a bit frustrating. I sure hope it's not my keyboard, because it was not the cheapest of keyboards. There we go. So it works for the example, but does it work for our input? We get a number, we don't get any crashes, so that's a start, I guess. And that is the correct answer. I will be cleaning up, but I'll clean up after part 2, which might throw a wrench into the works. So let's take a look at part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? That does not sound much harder. So I think for every hand, you just take a look at the lowest. This should be 1 red, right? 4 red. Where is the 4 red? Oh yeah, there's a count here. You have to take the highest. Yeah, you have to take the highest for every color you've seen. In one hand, the highest number you encounter is like the minimum amount of cubes for that color. That makes sense. And then there's a new calculation. Power of a set of cubes, multiply them together, the color counts, blah blah blah. So it's not the game IDs anymore, it's just some kind of multiplication of the color counts, but that's... Oh yeah, the numbers, and that would probably be 48. Where's 48 coming from? Is it the multiplication of these things? 4 times 2 is 8 times 6. 8 times 6 is, oh god. My brain can't even do basic multiplication. But I'm guessing it's 4 times 8, right? 8 times 6, sorry. My brain must have really been fried. Yeah, okay. I'm a bit shocked myself at the limits of my cognitive capacity. So yeah, let's do this. So we just need to, instead of doing the is possible filtering, we just need to map a game to like what's the least amount of cubes for every color to make this possible. What's the fewest number? Sounds doable. So instead of filtering to is possible, as we're doing here, we just transform the games to like a representation stating the minimum constraints for every color. So instead of a filter, let's do a map. and let's go crazy. And that's what our initial type was like, right? So yeah, instead of a hands list, we're just gonna have to have a hand list, would still work. Actually, it's one hand. It's not really the correct terminology, but it's one hand we need to build up from all the hands we've seen in a single game. I'm just gonna keep it like that. I'm not gonna make it more, introduce any more types. So given a game, return me one hand representing like the minimum viable set of cubes. And we can do that by iterating over all the hands. So let's do that. What's the correct word for what we're trying to do here? Let's call that minimal. Let's call that minimal. I'm blanking on names. So, build the minimal hand given a game. And that's just a hand. And it's a list of colors and edges. So yeah, that should work. And it's mapping to minimal, and then we need to do some other stuff, right? We need to calculate the power of the hand and stuff like that, or of the cubes. So how will we do a minimal? We need to look at every hand individually. And whenever we encounter a color, we have to find the max per color, right? We have to find a max per color. We could do that by looping over our hands 3 times, once for each color, or we could loop over it once and build up the tally for all 3 colors. That's actually maybe cooler. And then it does make sense to keep a kind of state object. I'm going to do it. So I'm going to declare a new type, state, which is literally our hand from a few minutes ago. So it's a red count, a blue count, and a green count. And we're going to build this up while we're looping through all the hands in a game. This smells like something I do a lot in F#, which is folding. And fold, if you look at the signature, it's saying you need to provide a folder function, which takes some state and an element in the list and returns some new state. It also takes an initial state, and it takes the list, which is our hands. So I'm going to fold over every element in the hands list, provide some initial state, which is whatever, 0 for everything, and then we're going to basically build up that state whenever we investigate a new hand. So it takes the state and a hand, and it returns new state, and our initial state is no greens, no reds, no blues. Yes. And now the thing we need to work on is this, our folder function. I'm gonna call that whatever. Visit hand. Yeah, there we go. So what do we need to do for every hand? We need to look up the colors, and we had that in part 1. I'm gonna grab that again, because we still need it. We need to have the color count. And now we update state, and if we have a count that is higher than what we currently think is the maximum, we just update it, and otherwise we keep the same state, right? So we can return state. I'm just gonna type this out. So we're just gonna copy paste the state property by property, red, blue, green. But now we can just put if statements here and there, or like conditionally update the state if this is better than what we have. So if RC is bigger than state red, then RC otherwise. So this would be an approach to do it. Or we could do other impressive stuff, but let's keep it simple. Let's keep it simple. So let's start with this approach first. Yikes. Okay, so now we have at least something to iterate on. And we have our minimals, which is a list of states. And then we just need to calculate the power for every set of cubes, which we call state right now. And that's just a product of those three. So let's write a function that calculates the power of a state. And that's the product of those counts. So now we calculate. We don't need to take into account possible games anymore, right? No. So yeah, we can just map our minimals to their powers. And then just sum the powers. Can I do that in one thing? Sum by? We can. So I think this might actually be a first try at solving part 2. 11,000. That's very incorrect. Okay, let's take a step back. What's going wrong here? Let's take a step back and let's start printing out what we're doing here. So this is clearly wrong. Let's take a look at I'm doing some aliasing so I can just select these lines and run them. So parsing our hands, I think that has not changed for part 2, so I'm pretty confident that still works. Let's take a look at the minimals for every game here. This looks very incorrect. We're just this looks very incorrect. We're counting like 4 reds, 4 blues, and 4 greens for our first game. That, no. What are we doing wrong here? Oh, I already know. This is the red count. This is not the blue count. Oh, dear me, dear me. And this is the green count. So, attempt number 2. Problems with a REPL is if you only like reload part of your code, sometimes it gets confused, but there we go. We have our non-buggy minimals, hopefully. 4, 4, 11. Is that correct for game 1? It's definitely not correct. So it's not even better, I guess. Oh, but it's taking, yeah, okay. It was taking the input, not the example, so let's try that again. 4, 6, 2, that sounds better. 2, 6 blues, 2 greens. Yes, game 2 is 1, 3, and 4. 26, 13, 14, 3, and 15, and 6, 2, 3. That actually looks better. So Let's run it on the entire example. 2286 is correct. About time. Let's put that in our one and only beautiful test. I have not been using tests as much as I used to, and it has already shot me in the foot, I think, 3 times in the last couple of days. So, lesson learned. Starting tomorrow, I'll be a bit more disciplined. But anyhow, let's solve part 2, right? We have a biggish number. And that is the correct answer. So, not very proud of my work today, but we got it. Let's take a look at our code. Let's see if we should or want to clean up anything and do a quick recap, all right? So, what did I do? I parsed these things into some kind of data structure representing games, hands, and colors. I started with regular expression parsing and then quickly found myself in too deep of waters. I could not actually do it, so we went to string splitting, which works, I guess, but there's alternative approaches out there. Once we have parsed this, then we need to do some constraint programming, find like the minimal viable set of counts for every color, so every random grab would match. And we did this by folding, so we have a List.fold down here, which just loops over something and like keeps a counter or whatever you want to do, whatever you want to aggregate. And we wanted to aggregate like the most amount of cubes for a color we've seen. So that's what we're doing here. And then we have this very big try to improve the state if it's necessary to improve the state or increase it. And if I were to clean up anything, it's this that I would clean up. But I'm not going to, my brain is fried. But yeah, that's a bit looking up like what color is in this hand. We played around with try finds. I think that's the first time this advent of code. We played around with option default values. But then in the end, we just have a big if statement in here. We could retry this to like have the state and update the red count conditionally and update the blue count conditionally with like a pipe operator. Maybe that's some fun rework we can do. Because this looks, even the formatting, look at this. Like the red is on one line and then this is indented, this is indented. I don't even know what my auto formatter is thinking, but this is weird. And it all reverts to it, so yeah. Let's maybe do that. Let's clean up this mess. Just as an experiment. So we can do state. Will it actually be better? It is possible to do, but no, I'm not even going to clean up. I'm calling it a night, or I'm calling it a morning because it's really early here. We solved part 2, we solved part 1. We hit some bumps again. I don't know how long we've been streaming. 48 minutes for day 2. That's impressive. But it was a fun puzzle, actually. Yes, I had fun. And I realized that I need to dig into regexes really soon. So that's what I'm going to be doing today. But we got our stars, and that's what counts, right? Having fun and getting our stars. That's it for today. I hope you had fun, and I'll see you tomorrow for day 3 in Advent of Code in F#. Bye-bye.